vamos a continuar con el último panel de la jornada, la pisada submarina que se renueva en búsqueda de una menor latencia. Muy bien, Michel, en los planes que tienen en Seaborn de nuevos tendidos para la región, ¿qué toman en cuenta con relación a la extensión de la ruta y a las propiedades tecnológicas?
In terms of, considerations, internally, we've been, analyzing some opportunities right now. As we said, this morning, we take in consideration basically three aspects when deploying a new, system or extending our existing cable. First one is the need of connectivity, right? The second one is, the demand, right? We need, new systems to cope with, data growth or a specific demand in one specific location. And then the third one is to replace existing infrastructure, right? Well, in terms of, right now we are evaluating several initiatives. We have one in the Caribbean area and also Central America. We've been evaluating the possibility to extend our cable to this region. We've been developing the right relationships and talking to the right stakeholders to deploy this new infrastructure. Also, we have another one in Brazil, which is the extend our cable to Recife, the city of Recife, in the northeast area of Brazil. As I said earlier, we just signed a MOU with a strategic partner in that region. This is, important region in terms of, economy, and it deserves, the right infrastructure in terms of telecommunications, data center, and etc. Hopefully, we are going to be announcing the type of infrastructure over the next few weeks. We still have some steps to get done. And then, as, a strategy for Brazil and also Argentina, I would say, we've been evaluating to extend our terrestrial presence in both countries, right? We've been discussing with strategic partners. We're going to have, a new POP in Fortaleza, as I said, also Recife. Potentially, we go to the south area of Brazil, and we are expanding our network outside São Paulo city. So there's been a lot of, right? In terms of technology, we've been, working with, good vendors on the, technological piece of the, the whole project, right? And, as a, by design, we are gonna, use, the latest, versions of any equipment, right? We have, some good, strategic partnerships in place in terms of equipment, cards, and, we are gonna, use them as advisors, to have the best equipment for each region.
En el caso de EllaLink, ¿qué tomaron en cuenta para el cable que unirá Brasil y Portugal?
This route is a new route. As such, it is a thin route. You can't expect a lot of traffic, or let's say you can't expect in the first years of operation a traffic that would be even close from what the traffic is between the US and Latin America. So our decision was around a balance between how much capacity we would be able to put on that cable and the cost of that. So I think one of the main decision was the number of fiber pair we would put on the cable, very simply. I just want to oversimplify, because in terms of technology, our choice was to select a vendor, Alcatel Submarine Network, and as the other vendors, ASN or Subcom, at the moment you sign, usually you get the best technology available on the market the day you sign. So you don't really have to choose which technology really. I mean, there are a few choices you make, but the real decision is around the number of fiber pair you make. And in our case, it was about CapEx, and I mean the amount of money we could afford with our business plan. And we picked up a number which is 4. Okay, at this moment, most of the cables are a lot bigger than this. Okay, so that remains a small cable if you compare to the current standard of the industry.
Ricardo, en el caso de Siena, en los planes de nuevos tendidos submarinos para la región, ¿qué herramientas tecnológicas demandan los operadores para reducir la latencia?
If you look at this long submarine cable routes, I mean, latency is really dictated by the total distance, right? So if you take light traveling an optical fiber, it doesn't travel instantly. It takes, let's say, 5 milliseconds for every 1,000 kilometers, or 10 milliseconds to go and come back, which is the turnaround time that we normally measure. So selecting the route is really the primary factor to reduce all the latency, right? So, and even if you do that, the shortest point between 2 landing stations is never a straight line, because you have to go around all those mountains and valleys in the seabed. So if you look at a Google Maps picture and select the satellite view, you see that it's never flat. And even, I think EllaLink has a nice blog they publish about the Mid-Atlantic ridge, which is super interesting. So you see that, I mean, you have to look about the route. So this is the first thing that you have to do. And these latencies, I mean, they are in the range of, if you want to go Brazil to the US, you're going to be looking at maybe 100 milliseconds. If you want to jump to Europe, it's 60 more. And if you look at the EllaLink's route, they are managing close to 100, or more precisely 98 milliseconds. I know 2 milliseconds is a big deal because it's 2% improvement. So, I mean, that's where the really improvement in latency can be found. From a technical perspective, there are some ways that you can minimize the latency, but really the latency that's being added by the equipment is really in the microseconds range. But one thing that you can do to improve latency and bring a whole lot of benefits to your network is what we here at Siena, we call GeoMesh Extreme, which is really trying to extend the network not only to the cable landing stations, but going all the way to the POPs or to the data centers, so that you can eliminate all those unnecessary optical, electrical, optical conversion stages that you normally have in a traditional scenario, right? So if you look at data centers, they are at times not located close to the beach, because you want to be away from any risk of floods, of any risk of tsunamis. So that means to reach that, you have to backhaul your traffic all the way. And we heard from Philippe the importance of backhaul, also from Sparkle, having diverse routes. But if you really want to optimize your end-to-end transmission, you could use this technology to every step on the way. You don't need to convert back to electrical and again to optical. So reduce cost, reduce complexity, you reduce space and power, increase your security. So there's a whole lot of benefits that you can do, and just reducing latency is one, let's call it, side effect of deploying that technology. So if you look at EllaLink's example, for instance, cable landing station is in Sines, but a data center is in Marseille. So if they want to, they can go straight optical all the way from Fortaleza to Sines, optical all the way, going to Lisbon, going to Madrid, all the way to Marseille. So this is one of the advantages. So if you add all those conversions, you're not only saving in latency, but also saving a lot of space, power, and cost, really, because every time you deploy a transponder, you have to buy 2 cards back to back. So you're trying to avoid all that. So really, that's one thing that we see, and it's available. I mean, that's what we're deploying with many customers. So it brings the benefit of reducing latency, but really choosing the route is the best way, the most significant way to reduce latency overall in a subsea cable.
¿En cuánto cree que se debe reducir la latencia de esto que estábamos hablando en los próximos tendidos para la región, teniendo en cuenta el aumento de tráfico que estamos viendo en este 2020 y los nuevos consumos asociados con esta pandemia?
It is hard to, to say what's going to be the ideal, latency, right? As, Ricardo explained, it is a, physical limitation, right? A point and Z point, depending on the route. But to mitigate that, what I've seen is that, the big, cloud providers, OTTs, they are, installing, they are bringing, their content closer to the end users, right? I can tell specifically here in Brazil, and we've been seeing this in Brazil, Chile, and Mexico, all the data center, companies, they are building up, huge campuses, in Chile, Brazil, or in China. Most of the, OTTs are installing, huge infrastructure here to provide and to be closer to the end customer, right? And also, I think that the next step, given the fact that 5G is going to be deployed in some countries, we're going to see, latency also will be critical for the applications, right? We have, IoT, autonomous car, everything that is coming with 5G. And then we're going to see the next step, which is the edge pods or, edge computing, edge data centers, right? So for, a cloud provider, OTT, to mitigate this, latency issue, especially the gaming companies as well, they are, bringing the content to the border, being closer to the, end customers. That's, the way I see, to mitigate, the latency issue right now.
Con estos cambios que generó la pandemia, ¿aceleraron la adopción de innovaciones tecnológicas para los cables submarinos? ¿Cómo fue la posición ante esto?
Yeah, absolutely, because if you look at the pandemic effects, I mean, it has changed the way we work, we learn, we live, right? So you do see an increase of demand for capacity, connectivity, and availability in what we're calling now the new normal. So this is going to stay for a while, and even after it goes away, those, I mean, the way that we're doing things now will likely stay like forever, right? So working from home, there's lots of changes in the way people see your work. You don't have to go to an office to sit in a desk and work all the day. So we're going to see that as a permanent effect. So anything that can be done to add more capacity quickly, if it's a new technology, if it's something new, it's being very readily adopted. So, and the issue with when you look at technology for subsea cables is that you have basically two parts, right? So if you look at an open cable, it's the wet plant, repeaters, cables, branching units, and the terminal. So on the wet plant, once that is deployed, it's very difficult to go and change that. So once it's in, it's in. And that's why the wet plant is always designed with the latest technology at the time that the contract is signed, as Philippe mentioned before. So something that is being loaded today was likely manufactured months ago. And even once the repeater and cables are already loaded, it may take a few months to finalize the actual installation. So it's a long cycle, right? That doesn't mean there's no innovation. It's just the cycles are longer between you deciding to do something or to adopt a technology and the technology being actually available to be used. But it doesn't mean there's nothing to be done, because that's the beauty of the concept of open cables. You deploy your wet plant, and maybe 2 years later, you go to the market and say, okay, I want to buy the SLD, which is the terminals that are going to light those fiber pairs, right? This is actually what Sienna does. So within the SLD, you have the modems or transponders, as it's called. And this is where we've seen a lot of innovation recently, right? So we moved from 200 to 400, now to 800 gig in just a few years. So specifically about Sienna, we have already commercially available in the market what we call WaveLogic 5, which is from our WaveLogic family. We have a 40% increase in capacity per fiber pair because of that. And that is reflecting in spectral efficiency. So you're able to fit more capacity in the same spectrum. And when we compare it to our previous ones, we see that being adopted very, very quickly. If you look at a terrestrial segment, and I think we're going to have a presentation by Rafaela, who's going to talk more about that. You can reach up to 800 gigs, but for subsea, because of the long distances and the way the systems are designed, you're likely to see 400, 500, and sometimes even 600 being deployed. So this is being taken very quickly, especially on subsea networks, because spectral efficiency is really king. These assets, they're expensive to be deployed. So the need to optimize the use of that capacitor or that bandwidth is really what's driving the adoption of all those new technologies, right? So the project's been around since April. I think we have maybe roughly 1,500 modems deployed, 40 customers, and half of that are subsea. So subsea customers, they're really grabbing that because they need the capacity, because it increased the demand that they're seeing these days. So we're seeing a lot of uptake on those latest technology, especially on the modem side. So I think about maybe 11, 12 networks already having a traffic going over it. So from let's say April up to now, I mean, everything that's already ready to be shipped and deployed, they're taking that very quickly because they need that capacity. So again, going back to my comment, yes, it has been accelerated, not only getting or adopting new technologies, but anything that will help increase the overall capacity of these links. That's, I mean, give me more, and that's what we're seeing since the beginning of the pandemic.
Filipe, en el caso de Fortaleza y Sines, en Portugal, que serán los puntos de amarre del EllaLink, ¿qué infraestructura vienen desplegando como parte de este concepto playa-playa que propone este proyecto que tienen?
The infrastructure we're building, it's largely in Sines and to a very little extent in Fortaleza. As I said in the previous topic I covered, we're landing in Fortaleza in the cable landing station of Celsius, our partner for this landing, and we're using an existing building in which we're building a little cocoon of for our cable that does not generate a significant amount of construction work, really. To the contrary, in Sines, and this is probably very important to note here, we're building a new landing station. So it's a building. You'll probably see on our website or LinkedIn page a lot of pictures of that. And I should say as well that this is a new landing for cables. The industry usually tend to reuse existing landing places. In the case of Santos / Praia Grande, that does provide benefits because having more cables coming to a beach, then you have usually a more dense backhaul network to the cities that are behind. In the case of Sines, it's a new landing, so we had to build a significant infrastructure to meet our needs, and that includes therefore the cable landing stations and the backhaul that are connecting that beach now to Lisbon and Madrid, further down Marseille. We do believe that this is EllaLink is the first cable to land, and there are going to be other cable landing in Sines. Given the geography of that, it's a nice area to land the cable, sandy beach, lots of lenses available, lots of power, and we believe this place will become a very well-known beach in the next 10 years.
Bueno, entre las preguntas que nos llegaron, Pamela Gidi, subsecretaria de Telecomunicaciones de Chile, consulta, que entiendo que es más para Filipe quizás, dice, Europa y Sudamérica pueden conectarse a través de Estados Unidos. La ruta Estados Unidos-Europa es muy barata y la ruta Sudamérica-Estados Unidos es cada vez más competitiva. Por ello, la ruta Sudamérica-Estados Unidos-Europa es más larga, pero puede ser más barata. ¿Cómo manejan eso?
We have to be competitive. I don't see how, let's say that if we had the idea to be more expensive than the route that combines, say, Seaborn with Aquacom, I'm just naming these two guys. I don't want to make any problem here. We would have a problem. We would not be selling. So I think our cable is designed to make sure that we are and will be competitive compared to a longer route. That's quite obvious. That's a very important point. If we were not able to be as competitive as the longest route, then it would mean there is a problem with EllaLink. And frankly speaking, I don't think we're going to have that problem. We will be competitive.
Para Michel, tenemos una consulta. Quisieran ver si nos puedes comentar un poco más del proyecto futuro del ARBR que llegaría a Argentina, si sabemos que es para dentro de unos años, pero si puedes adelantar algo.
We've been discussing with a international customer for some time, and we are signing an agreement where we will operate a huge pulp in Argentina. Okay. We are going to reach Argentina not with our physical infrastructure, our own infrastructure. We are going to use a third-party partner, but that's what I can tell right now. But this is going to be a game changer for us, certainly. Okay, and then we're going to replicate this also in Brazil and in other countries in Latin America. But unfortunately, given the fact I have an NDA, I'm under NDA, I cannot release more information. But it's going to be a huge release over the next few months.
Abres un poco la intriga aquí al final del evento casi. Queremos saber si coincides con la visión de los dos caballos planteada antes por Andrés de Infinera.
Yes, I mean, clearly there are two technology providers that have been working with 800 gig for a while. So yeah, I agree with that. I mean, the products they use similar technologies. They very smart people in both companies. I mean, I myself worked with Corient years ago, so I know smart people there that are now part of Infinera. The difference, and it's a key difference, is that our horse is already running. Their horse is still at the stable, being fed, getting ready for the run, because we have the technology available, being deployed, being shipped, and being used. They're working hard, and they will get there. And when they do get there, I'm sure they're going to have a great technology, but they're not quite there yet. So they're still feeding the horses. So eat more hay. I mean, getting stronger, but still not running yet. So we are, and that's the one difference that we see today. May change in the future, but for now, but I agree, the two companies, they're leading the pack by far. So yeah, great technology in both sides.
Gracias, Ricardo, por agregar un poco de picante acá cuando ya estamos con un día agitado, así que nos despiertas un poco con tu visión. Les agradecemos mucho a los tres integrantes del panel.